So basically what we do is we build refineries and they are modular. So we provide a technology, we provide the entire drawings. Most of the equipments are built here. Typical size of these refineries, they are laid on 5 to 10 acres of land. So that is the size of construction. So that is the introduction, and there we build a lot of steel structures. So that is why I'm here today. Yeah, I will not go much detail into this slide because a lot of experts has already discussed these points. So the technology basically, right from the modeling, end users expectation, then modeling, and then using of advanced material, structural design, and 3D modeling, which will end up to the production. So what is the concept of the architect or a structural design? The elements will be transformed to the actual production. So this is the size of a refinery. The top photograph shows the finished refinery. And there are a lot of buildings and the equipments. I'm just showing one model in the top left building. That is the conceptual model. So the entire model is built. Then fabrication drawings are issued. And this is the end product. And this is a section one of the building. There are multiple this thing. You can see the complexity of this, where there is a lot of automation, steel, and everything is modular. Everything goes in the container. These buildings are assembled. This particular project was assembled in 22 days. So it is fabricated, assembled in the factory, tested, dismantled, and placed again. This is another example. And these are the three photographs I combined just to give a scale: a tank farm, a refinery, control room. So 4 or 5 years back, I was want to build my own house, second house, and I approached to our friend, architect, and our structural engineer. So they came with the idea that they said, let's reflect what you do in your house. This is the example I just want to place here. So this model was initially made in the beam, and then I converted it to in the 3D modeling in SolidWorks, because that's where we are going to build. Most of the things are in structural steel. So this is the basically top portion of the house, the living room and 3-4 bedrooms. This is 36 meters by 16 by 4.5 meter. This is elevated and placed on 10 meters, 9 to 10 meter beams, 9 to 10 meter columns. Everything, each part of this is modeled, right from the dining table to the kitchen to everything, and so that it can be assembled. All these top portions are cross sections where the beams, I-beams, and structural steel is designed, modeled, given it to CNC in our factory, automatically cut, then weld. Everything was assembled in the factory, dismantled, and put it back there. You see, if the spans, the beams are around 12 meters, total structure is 36 meters, it means the entire structure was in 3 pieces. The span between the two columns is 16 meters, so you need some support to support that 12-meter structure, which is around 30 tons. So this is the picture. I'm just showing how the assembly was done. This is after the assembly is complete. If you look at the roof has just 1.5 degree angle. Normally you will not get that kind of sheets. We got these sheets from Kingspan, where they are ready to give 1.5 degree slope. This is 4 meter by 16 meter cantilever. This structure is designed by Girish David. And you can see the columns are around 9 meter high, 4 meter projected by 16 meter. The grating is made of 1.5 mm carbon steel. They are formed, punched. They are available in 4 meter by half a meter. Similar gratings are put on the for the rain beating on the top. This is the product after the house is finished. This is 12. The glass slidings here are 12 meter by 4 meter. That kind of opening. Ultimately, we have to limit it because the glass manufacturer, I mean the sliding manufacturer, that is the maximum size they could give us. The span between the columns is, I already told, of course, there were a lot of projects, we were talking about 100 meters, but this is a house project, so this span is around 16 meters. Everything is nut bolted, around 3,000 to 4,000 nut bolts are there, and the accuracy, I mean, the whole clearance was only 2 mm. So everything has to fit into 2 millimeters. It should be confirmed because you cannot do anything on the top. Not a single weld was, no welding was done on the structure. So everything fit as it is, whatever is made in the factory. So the steel structure opens an enormous opportunity for design, for architectures, as well as structural options. You can do anything, whatever you want. And this is the beauty of the structure. That is the small presentation I want to give you. Thank you.